Well, now that we've talked about probabilities with or and not, now we're going to start to talk about probabilities with the word and. So looking at two different occurrences happening together, and what's the probability that they happen together, different events. And so here I have two different situations. You can have either independent events or dependent events. So you can have two things that if one of them occurs, it affects the probability of the other. Those are dependent events, or where they both occur individually and neither one affects the probability of the other. That would be independent events. An example, a really good example of independent events, coin tosses. You get two coin tosses. Flip it, that one's tails. Tails. If you do it a second time, the second one, the chances of it coming up heads or tails is not dependent upon the first one. That was tails again. And so, interestingly, individual coin tosses have no effect on future coin tosses or past coin tosses. They're all independent of each other. Same with the roll of a dice. You roll a dice, you roll it a second time, you roll it a third time. The odds of a 6 coming up are the same. All, no matter how many times you roll the dice, the odds of an even coming up are all the same. The probability never changes based upon the first outcome. Okay, so these are independent events. Dependent events are different. Dependent events occur where one thing occurs and then a second thing depends upon the first. It'd be like a deck of cards. If you deal out a hand of poker, for instance, and the first card you get dealt out is a 6 of spade. Well, the probability of anything else happening is now changed because that card is out of the deck. Okay, and it's not a big change, right? It goes down from 52 cards to 51, but it is a change. Some of the changes are more drastic than others, but still, the probability of a later card is dependent upon the cards that were already dealt out. Okay, so those are dependent events. An interesting example and a very common misconception is that if you get a whole bunch of coin tosses, for instance, that are the same, they're just got a heads, you keep tossing the coin, and let's say all of a sudden you're getting tail. You're like, okay, the chances of it being heads are better now because all the tails occurred just now. Well, that's not true. The chances of a head coming up next are still 50-50. The probability is still the same. Okay, and so people often get these two ideas confused, where they think that a whole bunch of past, past outcomes may influence future outcomes. They really don't. All right, I see an interesting example of this. Recently, I had gone to a trivia night at a local bar with some friends, and we were participating in this activity. And towards the end, they took a little intermission, and they offered a free drink to anyone left standing after doing a coin toss competition. And so everybody stood up, and you put your hands on your head or on your tail. And the guy, the DJ or whatever, he flipped the coin, and if it came up heads and your hands were on your heads, you stayed up. If your hands were on your butt, you sat down. If it came up tails, then obviously if your hands were on your butt, you stayed up. And anyway, he just did it over and over again. And last person standing won a free drink and a mug. And so I stood up and I'm like, oh, I'll go tails. I had heard somewhere along the line that tails are slightly more likely to come up because the head is heavier, but I don't know that that's actually true. And the amount of times that really affects anything is probably negligible. But I went with tails. I usually go with tails. Anyway, went with tails, and it was tails. And so then so half the people sit down basically, and then you got half the people stand up, whoever had their hands on their butt. And then he flipped the coin again, and I kept my hands as tails, and it came up tails. Did it again, it was tails. Did it again, it was tails. 5 times out, it was still tails. And at that point, there was only 3 of us left. So there were 3 weird people who chose tails on the first 5 tosses, and it happened to come up tails every time. Okay. Now the odds of each individual tail coming up is 50%, 1/2, right? The probability is 1/2, not the odds. The probability is 1/2. And so the probability of the next coin toss coming up tails is still 50-50. Well, 3 of us are left, and he says, all right, everybody get your hands on your head or on your butt or your tail. And I started out saying, well, it's been tails every time, I might as well ride it out, right? Keep going with it. And I looked at the other 2 people, and I saw they had the same thought. Like, we're all on tails. And I thought, no, the odds are better if I'm different. And it doesn't matter if you're heads or tails at that point. It matters if you're different. And so the probability of, see, these are each independent events. So the probability is the same, 50-50 either way. And so you're not trying to figure out, okay, when's it going to change? Are the odds, or the probability is better now that it's heads because all the tails that occurred? No. It has nothing to do with that. Nothing to do. The next coin toss is the same exact probability as the last coin toss and the first coin toss. They're all the same. What made me change my mind and go heads, and I ended up winning, is that I knew that the other 2 people were on tails. And if I stayed on tails, then either we were all going to sit down because we all get it wrong, or we were all going to move on to the next round because we all get it right. And that's not a place to be at. You don't want to be in the next round with everybody again, having to get it right again. And so at that point, I knew that you got a 50-50. If I go different, right? If I go different than everybody else, I've got a 50% chance of losing. All right? If it comes up tails, I'm done, and they move on. But I got a 50% chance of winning that round, which in that case would have eliminated them and given me the free drink. Okay? So it's a 50-50 chance of getting the drink. However, if I had stayed and won, I would have had to play again. And so the probabilities multiply. And so a 1/2 probability of winning that round would have then become a 1/4 probability when I multiply by the 1/2 probability of getting the next round, and so on. And so the probabilities of winning, if you stay in the game, actually end up going down the farther out you go because of the multiplication of the probabilities. And so what I determined was that the highest odds I had were a 50-50 chance, and that was by being different than the other 2 people. I ended up winning, but that was only by chance, right? By 50-50. It didn't have to be that way. I could have lost just as easily, but I knew that I had to be different in order to have the highest probability of winning the competition. Okay. Anyway, it was just kind of a neat example of where, where a future coin toss is not influenced by prior coin tosses. It doesn't matter if there's 50 heads or 50 tails in a row. The next one's not necessarily going to be heads, and the probability of it being heads is not determined by the 50 prior tails. It has nothing to do with that. It's still a 50-50 chance of being heads or tails on the next roll, on the next flip. Okay. I've also seen this sort of thing playing a game there. Settlers of Catan. I don't know if anyone's ever played that game. You roll die when it's your turn. You get 2 dice and roll them, and you're trying to collect different goods like wood and brick and ore and sheep and I don't know, was it wheat or something. You're trying to trade goods and build up points and build settlements and railroads and all this kind of stuff. But anyway, it all is predicated upon rolling dice, 2 dice at a time, and adding the sum and the number of ways that 2 dice can add up to 7. 7 is the most likely outcome because it happens with the most combinations of numbers, and then everything from 2 to 11 2 to 12 sort of falls in outside of that as a lesser probability. And so it's very common to think, well, the 6s are coming up a lot, so that means they're not going to come up in the future. No, the probability of a 6 coming up is the same on the next roll as it was on all the other rolls. It doesn't matter what the past rolls were. They're independent events. Okay, so anyway, that's a long-winded way of saying independent events have no way of influencing future events, whereas dependent events do. Okay, so I'll talk a little bit more about these, and we'll do some examples in the next video.